y equals sin x, sine function. Domain is all real numbers. Range,
inclusive interval between -1 and 1.
let's sketch the graph. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0, negative pi over 2, -1, negative pi 0. Then connect these points smoothly. It's an odd function because the graph is symmetric about the origin. It's not one-to-one function. When we draw any horizontal line, we got two intersections, so it's not one-to-one function. Increasing interval from negative pi over 2 to pi over 2 plus 2k pi plus 2k pi. K is all integers. Decreasing function. Let's use this part. From pi over 2 to 3 pi over 2. Every 2 pi repeating plus 2k pi plus 2k pi. K is all integers. Y equals arc sin x is the inverse function of sin x. Name inverse of sine function. Since sine function is not one-to-one function, how we get inverse sine function? Restrict the domain of this sine x to get inverse sine function. How did we restrict the domain? We make domain of this sine x between negative pi over 2 and pi over 2.
In this way, we got one-to-one function. So for inverse sine x,
range is between negative pi over 2 and pi over 2. Domain is between -1 and 1. Let's make a table. 0, -1, 1, 0, negative pi over 2, pi over 2. Let's add another 2 points. Pi over 4, square root of 2 over 2. Negative pi over 4, negative square root of 2 over 2. Plot these 5 points. 0, 0, pi over 4, 0.7. Estimate here. 1 pi over 2, negative pi over 4, negative 0.7, negative 1, negative pi over 2. So we can sketch the graph like this. This is an odd function because it's symmetrical about the origin. It is a one-to-one function. From left to right, the graph is increasing. So, in his domain between -1 and 1 will be the increasing interval, no decreasing interval. Y equals cosine x, name cosine function. Domain is all real numbers. Range is between -1 and 1. Plot the points 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1, negative pi over 2, 0, negative pi, -1.
Connect these points smoothly.
This is an even function because the graph is symmetric about y-axis. It's not one-to-one function. When we draw any horizontal line, we got more than one intersection. Increasing interval, we can use this negative pi to 0, every 2 pi repeating, plus 2k pi, plus 2k pi. K is all integers. For decreasing function, let's use from 0 to pi. Every 2 pi repeating. K is all integers. Y equals arc cosine x, inverse cosine function.
Since cosine x is not one-to-one function, we restricted the domain from 0 to pi. For inverse cosine,
Domain is between -1 and 1. Range is between 0 and pi. Let's create a table. 0 pi over 2 pi. Cosine 0 is 1. Cosine pi over 2 is 0. Cosine pi is -1. Let's add pi over 4. 3 pi over 4. Let's plot these points. Then sketch the graph by connecting these points smoothly. This is not even or odd function because it's not symmetrical about y-axis. It's not symmetrical about the origin. Neither. It is a one-to-one function because when we draw any horizontal line, we only get one intersection. From left to right, the graph is going down. So the decreasing interval is between -1 and 1. No increasing interval. Tangent x. This is a tangent function. Domain tangent x. This x cannot be equal to pi over 2. Every pi repeating. So x is not equal to pi over 2 plus k pi. K is all integers. Range is all real numbers. Let's sketch the graph. First of all, vertical asymptote line. Every pi repeating 0, 0.
Pi over 4, 1. Negative pi over 4, negative 1.
Now sketch the graph. So for tangent function, vertical asymptote line is x equals pi over 2 plus k pi. K is all integers and odd function because the graph is symmetric about the origin. It's not one-to-one function because it's not passing the horizontal line test. From left to right, the graph is increasing. For increasing interval, x not equal to pi over 2 plus k pi. K is all integers, no decreasing interval. Arctangent x, inverse tangent function. Since tangent x is not a one-to-one function, there is no inverse function if we don't restrict domain. People created the inverse tangent x by restricting the domain of tangent x from negative pi over 2 to pi over 2. So range is negative pi over 2 to pi over 2. Domain is all real numbers. Since we have a vertical asymptote line for this tangent x, we will have a horizontal asymptote line for inverse tangent x. Y equals negative pi over 2, y equals pi over 2. Let's make a table. 0, 0. Tangent negative pi over 4 is negative 1. Tangent pi over 4 is 1. Negative 1, negative pi over 4. 0, 0. 1 pi over 4. Then we can sketch the graph. This is an odd function because the graph is symmetrical about the origin. It is a one-to-one function because it passes the horizontal line test. From left to right, the graph is going up. So it's an increasing function in its domain. For x, it's all real numbers. No decreasing interval. Let's label negative pi over 2, 0, pi over 2. This is the inverse sine and inverse tangent. Label 0, pi over 2, pi. This is for inverse cosine. From this diagram, we could say for inverse sine x, domain is between negative 1, 1. Range is
Inclusive interval between negative pi over 2 and pi over 2.
Inverse cosine function. Domain is between negative 1 and 1. Range is between 0 and pi. For inverse tangent function, Domain is all real numbers. Range is from negative pi over 2 to pi over 2. Use this diagram to remember the range of inverse function.